Hi everyone. Today we're going to talk about absolute value. We're going to start with the definition. What I want you to start with is evaluating f of x for the function absolute value of x for the following values. Then I want you to explain the relationship between the input and the output. Pause the video now and do this on your note sheet. So as you can see, absolute value of 4 is 4, absolute value of 7 is 7, absolute value of 0 is 0, absolute value of negative 1 is 1, and absolute value of negative 6 is 6. Hopefully one thing that you also noticed and wrote down was that if the input is positive, its absolute value is the same number. For example, the absolute value of 4 is the same number, it's 4. The absolute value of 0 is just 0. And the absolute value of a negative number is its opposite. For example, the absolute value of negative 1 is positive 1. We also do know the absolute value of a number is always positive because we're just measuring the magnitude or the distance from 0. We can use this property of absolute value to do absolute value transformations on the graph. In order to do an absolute value transformation, if the function is above the x-axis, it would stay the same. Just like if input is positive, you're going to get the same number when you take the absolute value. If the function's below the x-axis though, it's going to be reflected over the x-axis. Just like if you take the absolute value of a negative number, the answer is the opposite of that number. Pause the video right now and see if you can draw this correctly. So I'm going to start on the left side of the graph. This is underneath the x-axis, and so I'm going to reflect it over the x-axis, just like that. This part is above the x-axis, so it's just going to be the same part. This part is below the x-axis, so I'm going to reflect it. And then this part is above the x-axis, so it's going to stay the same. Therefore, the blue graph shows the graph of the absolute value of f of x. And do the same thing with this other function. It starts above the x-axis, so we start by drawing it there. Then it goes underneath the x-axis, so I reflect it over. And it continues to just be reflected over the x-axis for the rest of it. Now we go to our formal algebraic definition of absolute value. F of x equals the absolute value of x if and only if. So we can also write this f of x equals x for 0 to infinity, or if x is greater than or equal to 0. Or f of x is the opposite of x on negative infinity to 0, open, or when x is less than 0. Could also, if you wanted, put the open bracket here and the closed one there, just as long as it's still a function, because obviously the opposite of 0 is still just 0. Let's now extend this to any function. So for the absolute value of a function, the function will be the same for positive and 0 values of the function, and the function will be the opposite for negative values of the function. For example, if we look at the function f of x equals absolute value of 3 minus x plus 1, if we want to rewrite this as a piecewise function, or in other words, a multiple piece function, we need to apply this definition. First, we need to look at when the function inside the absolute value bars is positive. When it's positive, it's going to be exactly the same. To find where 3 minus x is positive, we set it greater than or equal to 0. By solving, we see that this will be where x is less than or equal to 3. Next, we consider the case where inside the absolute value bars is negative, which means that we need to make it the opposite inside the absolute value bars. To find where 3 minus x is negative, we set up the inequality 3 minus x is less than 0. Solving the inequality, we find this is for x values that are greater than 3. Now that we know where the expression inside the absolute value bars is going to be positive and negative, all we have to do is finish simplifying the expression. For the case where inside the absolute value bars is positive, we keep everything inside the absolute value bars the same. So 3 minus x plus 1, which would be the opposite of x, plus 4 after collecting like terms. When inside the absolute value bars is negative, we need to make inside the absolute value bars opposite, and that means the entire expression inside the absolute value bars opposite. That means I need to use a minus parentheses and make sure that the negative sign goes to both of the terms that are inside the parentheses. So this becomes negative 3 plus x plus 1. And then after collecting like terms, the expression becomes x minus 2. So in conclusion, the function has two pieces. The absolute value of 3 minus x plus 1 is the same as the function where f of x equals opposite of x plus 4 on the interval from negative infinity to positive 3, closed, and x minus 2 on the interval from open 3 to positive infinity. Make sure you practice with some of the practice problems on rewriting absolute value functions as piecewise functions, and also make sure that if you have any questions, either put them in the comments, ask them through Canvas, or ask me about them in class.